All right, we have made it to unit 2. I'm going to change the color just because I have changed the color for the other two. So let's go purple this time. So we've made it to the unit 2 study guide. This one was all about linear functions as graphs. So unit 1 was all about comparing linear functions and finding where they're equal, keeping that balance scale the same. And this one was all about the graphs and interpreting those graphs. So this one says, write the equation of this line. I'm going to zoom in on this line. So right off the bat, I can tell this line is going to have a negative slope because it is falling from left to right. So if it were going to have a positive slope, it would be climbing from left to right, but instead it is going downwards. So I know it is going to have a negative slope. And the way that we find slope from a graph is we do what we call a slope triangle. And they were nice enough to give us 2 points here that we can use. So I can do this slope triangle right here and find rise over run. So my rise would be negative just because I am going down. So 1, 2, 3, 4, 5. So I've got a negative 5 over my run is 1, 2. So that is my slope to start with. That's my M. And then my B is where I cross my y-intercept, or where I cross my y-axis. My B is my y-intercept. So right here, this is my y-axis. This whole thing is my y-axis. And my line crosses my y-axis right here at 0, 5. So I know my B is going to be 0, 5. So B equals 5. So I'm going to take this. So I've got my slope, which is negative 5 over 2. And I know that y equals mx plus b is the way that I normally write how I graph a line because that is slope-intercept form. So I have y equals, instead of m, I'm going to put in negative 5 over 2. I'm going to bring my x. And then my y-intercept was 5, so I have this. So let's see if any of my answer choices match. Oh no, I'm just writing it. Okay, so I'm just going to come put my pieces in over here. So my slope was negative 5 over 2. My b was 5, and so my equation would be y equals negative 5 over 2 x plus 5. And that would be the answer for that graph. All right, moving on to number 2. Write the equation of this line. So again, we're just going to pull the pieces out of it. They did give us some points there, so I can use those 2 points. So they gave me a point here, and they gave me a point here. And I can make myself a little slope triangle again to find rise over run. And this one I can tell is going to be a positive slope because it is climbing from left to right. So I'm going to go ahead and find my rise, which would be 1, 2, 3. And then my run, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I'm looking at 3 over 9 right here. And while 3 over 9 could be the slope of this line, we always want to make sure we write it in the simplest terms. So I can simplify this fraction by dividing both numerator and denominator by 3. So I'm going to go ahead and do that. And I know that 3 divided by 3 is 1, and 9 divided by 3 is 3, which makes the slope of this line 1/3. So that is my M. All right, again, I'm looking for the y-intercept. And the y-intercept is here, and it's somewhere between 0 and 1. It's probably a little bit closer to 0 than it is to 1, but I'm just going to give it a good estimate and call it 0.5. It doesn't have to be perfect here. We're just getting a good estimate. You could call it maybe 0.25. I don't think it's quite there. I'm going to call it 0.5. You can even call it 1/2 if you'd like. So I have a slope of 1/3, a b of 0.5. So let's come over here and fill in those pieces. So 1/3, 0.5. So my equation would be y equals mx plus b. Going with that, I'm going to go y equals 1/3 x plus 0.5. And that is going to give me that line that I just have right here in this graph. All right, from here, they want me to find the slope using these 2 points. So these 2 points, I know I can find the change in y over the change in x. And I know we've seen this several times written like this, delta y over delta x. So I have my 2 y terms, 6 and 8. So I'm going to take y2, so the second y, which is 8, minus the first y, which is 6, over x2, which is 7, so the second x, minus the first x. And then I'm just going to simplify. 8 minus 6 is 2. 7 minus 3 is 4. And I know that 2/4 will simplify to 1/2. So that is my m, my slope for that. Then I can go back and using y equals mx plus b, I can solve for my b using these x and y terms that I already have. So I'm just going to use the first one. So the y term for that is 6. I know that my slope now is 1/2. I know my x that went with that 6 is 3. And then I'm just solving for b. So that would give me 6 equals, and then 1/2 times 3 is 1.5 plus b. So I'm going to subtract 1.5 from both sides, subtract 1.5 from both sides. So that'll cancel that, and b would equal 4.5. So I have my slope, which we found was 1/2. I have my b, which we found was 0.5. And actually, they didn't even ask me to find b. I just went ahead and did that. So all they asked me to find was the slope. So you could have stopped here. And I just went ahead and found b. But you have it here. All right. From here, for number 4, and I am going to go ahead and erase that out of my way. Okay. So they went ahead and gave me the slope as -3, and then they gave me some x, y terms. So they gave me x is 2, y is -3, x is 3, y is -6, x is 4, y is -9. So I can go ahead, and what I went too far for on number 3 is what I am going to do on number 4. So I'm going to use y equals mx plus b. And I'm just going to use this first term right here. Either way, no matter which one you choose to use, if you use the xy pair, you will get the correct b no matter which of the 3 you choose to use. So y here is -3. I know my slope is -3 also. X is 2, and I'm just solving for b. So -3 comes down because I can't do anything with it yet. -3 times 2 is -6 plus b. I'm going to add 6 to both sides. That cancels and leaves me b equals -3 plus 6 is 3. So they said to write the equation for the linear function. So I'm going to take it, and y equals, my slope was -3. X plus the b I just found is 3. That is page 1 of the Unit 2 study guide. So I'm going to move on to page 2. Obviously, you can pause this and look at it as long as you'd like. All right, this just says, what is the slope and y-intercept of this equation? So they're just asking you, do you know what this slope is? And I know that y equals mx plus b. So I know that 3 is my m. That's my slope. And -5, not just 5, is my b. And that's all you have to do for number 5. They're just asking you to pick out the pieces of the slope-intercept form. All right. Number 6 asks you which relation is not a function. And to think back, you have to think back. We talked a lot about one package can't go to 2 houses, but 2 packages can go to 1 house. And that was kind of how we likened functions. So what we said was, and what Ms. Peoples really likes to say, is that you can't go back to your x because your relationship didn't function. So what you don't want is a repeating x term. So I'm looking right here at A, and I have 1, 2, 3, 4. That one's fine. That one functions just fine, okay? B, I have 2, 4, 6, 8. All right, that one functions just fine. C, I have 1, 2, 3, 4. All right, that one's good. And D, I have, 2, 2, 3, 4. So I do need to make sure I check and make sure that they're not the same pair. And they are not. 2 is with 2, and 2 is with 3. So 2 cannot be with 2 different numbers, which makes D not a function. All right. Number 7, very similar to number 6. 6 was an XY table. 7 is just coordinate pairs, but we are still, again, looking for where X repeats. So it says which one is a function this time. So all of these are going to have a repeating X except for 1. So the last time they were asking you which one is not a function. This time they're asking you which one is a function. All right, so A, all of my X values are 2. So that one's not a function. B, 1, 2, 1, 2. All right, those are repeating x's, not a function. C, 1, 2, 3, 3. Again, not a function. And D, 1, 2, 3, 4. So that one is my function. All right, when you are looking at, we call these a mapping. You're looking, same thing. You want no repeating x's, but it looks a little bit different on a mapping because they have these arrows that come through them. So let's look at A. So they're saying for A, 6 goes to 18. So that one works fine. 12 goes to 36, that works fine, but 18 goes to 36 and 54, and so that does not work because 18 can't go with those two numbers. So A is not a function. All right, B, 0 goes to 12, that works, but 4 goes to 12 and 15, and that doesn't work for it to be a function. All right, C, -3 goes to 9, that's fine. -1 goes to 1, that's fine. 1 goes to 1, that's fine, and 3 goes to 9, that is also fine. So it looks like C is going to be my answer, but let's go ahead and check D just to make sure, not sense. 1 goes to 32, 2 goes to 48, but 3 goes to 48 and 64, which makes it not a function. So C would be my answer. Sorry, I looked up at A and said A. All right, 9 says, given the relation, and they gave you these coordinate pairs, which of the following values for x will make this relation a function? So what they're telling you is that x cannot be 3, 1, or 6. So I'm going to mark out 3, 1, and 6. So my only answer choice here is 4. So that is page 2. All right, moving on. Okay, Gail is saving up to buy a new computer. She started out with $10 and makes $35 a week. How much money will Gail have after 4 weeks? So first, before I can solve for 4 weeks, I need to write my equation. So Gail is saving money. All right, fine. She starts with $10, so I know she's starting with a positive 10 somewhere. She makes $35 a week, so that 35, and I don't know how many weeks we're working yet, so I'm going to put an X because that's an unknown term. So this is my equation that I am using to see how much money she'll have after 4 weeks. And I know that weeks went with X because I put that 35 there because I didn't know how many weeks she went. So the X went with the 35 because we had an unknown term of weeks. But now we have a known term of weeks, which is 4. So 35 times 4 plus 10. Let me grab my calculator here because off the top of my head, I don't know what 35 times 4 is. So 35 times 4 is 140. Plus 10 equals $150. So after 4 weeks, as long as she hasn't spent anything, she will have $150. All right, moving on to questions 11 through 13, and this is a distance time graph, which you've also seen in science, I'm pretty sure, at this point. All right, so how far is Kevin from home at 10 a.m.? So I know, I'm just going to zoom in on this just a little bit so I can see it a little better. So here's 10 a.m. So I'm going to go all the way up until I hit my distance time graph, and Kevin at 10 a.m. is 40 miles from home. So I'm going to write 40 miles. So simple enough for that one. How long has Kevin been away from his house? I'm assuming they mean from 10 a.m. If they don't mean from 10 a.m., they didn't give me enough information to answer this, so we're just going to go with it. So Kevin left his house looking like at 7:30. So he was still home at 7:30, and then he left. So from 10 a.m. going back to 7:30, that would be 2.5 hours. Okay, what time did Kevin start to head back home? So we can tell, all right, so all this, Kevin's moving away from home, right? And then this, he hasn't moved at all. He's staying in the same position. That's why it's flat. So when he starts to head back home, it's going to start going negative. So he starts to head back home right about 10 a.m. And that's it for 11 through 13. Those are pretty simple. Distance time graphs are always pretty simple. 8th graders usually kind of latch onto them and don't really have problems with them. All right, so let's look at 14 through 16. So we're talking proportional and non-proportional. And remember, proportional has to have two things. One, it has to have a constant slope. So they have to be linear. 2, they have to go through the point on the graph, 0, 0. They must go through the origin. They must start at 0. Otherwise, it makes it unproportional because I can't divide anything by 0 without getting an error or a divide by 0 problem. So let's look at 14. I'm paying an admission fee of $15 at the fair and then $2 per ride. And I can already tell it's non-proportional because just to get in without doing anything yet, I'm going to pay $15. But let's write that out as an equation. It would look like this. So I know this right here means it would not go through the origin, so it's non-proportional. All right, my bank account doubles every month. While that may seem like it is going up by the same amount each time, it's not. So let's say I started with $2. The next month I'd have 4, so that's plus 2. The next month I'd have 8, but that's plus 4. The next time I'd have 16, that's plus 8. So it is not going up by the same amount each time. This is actually an exponential function. So it is not linear at all because it would grow like this and not like this. So you want that one to be non-proportional. And then a job that pays $18 an hour. If you do 0 work, you start at 0. So we're going to assume that that one goes through the origin. $18 an hour is a constant slope, so that makes that one proportional. All right, I'm going to zoom back out, and we're going to move on to the next page. All right, the point 6, y lies on the line F. If line F has the equation y equals 1/2 x plus 2, what is y? So what they have given me is an xy pair. And then they have also given me this nice little function here that's going to help me solve it. So what I have is I have a term for x right here that I can put in right here where x is. So y equals 1/2 times my x value they gave me was 6 plus 2. And I'm just solving for y at this point. So y equals 1/2 times 6 is 3 plus 2. So y equals 5. So the y term is just 5. And that's all you have to do is understand that they gave you the x term to plug in there. All right, 18, the point x5 lies on line P. So we're doing the same thing, and I kind of wrote over, yeah, so it's a -3. So 2x, so just remember that was 5. All right, so x and y, they gave me the y term this time. So they gave me 5 is my y term. 2, I don't know x still, that's what I'm solving for. So now I just have a 2-step equation. So I'm just going to draw my line here. Plus 3 on both sides to start isolating my variable. 5 plus 3 is 8 equals 2x. Again, I'm trying to isolate x. I'm going to divide by 2 on both sides. So that would give me x equals 4. So simple enough for both of those. All right, this is telling me they want me to write the table for this equation. All right, or write the equation for this table. I read that completely backwards. So I'm going up by 1 each time. Plus 1, plus 1, plus 1. So I know I can go back 1. Instead of having to solve for the 0 term, I can just go back 1. So right here, I'm going to have a 0 term. And I'm going to find the y term that goes with that in just a second also. So this is plus 6, plus 6, plus 6, plus 6. So to go back 1 term, I'm going to subtract 6. So 3 minus 6 is -3, which gives me my b is -3. I already found my slope. It was all those plus 6's that I was finding. So my slope is 6, meaning my equation for this line is y equals the slope that we found, which is 6x, and the y-intercept we found, which is -3. Oops, did that instead of dragging. All right, Dana works at Verizon Wireless, and she gets a discount on her phone bill. Below are her options. Option 1, pay a flat rate of $35 a month per unlimited. Or option 2, pay $20 a month plus $5 for each gigabyte after 10 gigabytes of data. Write the equations for both options. And I think we sort of just said to ignore this after 10 gigabytes of data and just assume it's not there. So for the purpose of this, these are supposed to be 2 very simple equations, so we're ignoring that 10 gigabytes. So write the equation for both options. So option 1 would look like this. Pay a flat rate of $35 per month. So 35, and then I don't know how many months I'm going to keep the thing, so I'm just going to put an X because that's an unknown term. And then 2 would look like this. So $20 a month, and then plus $5 for each gigabyte. So 20 is my flat rate in this case because it's happening several times. So plus, you know what? I read that completely wrong. So we're actually, ignore that. Ignore everything I just said about that. And I actually just erased that too. I'm going to try not to erase my questions. I read those wrong. So that's what happens when you assume that per means that's where your X goes. Option 1, you are just paying $35 a month flat. That's it. It's just $35 each month. Option 2 you're paying $20 the month plus $5 for each gigabyte. So what I have here is 1, no matter what you do, you're going to pay $35 a month. Doesn't matter. 2, no matter what you do, you're going to pay $20 a month, but you're also going to pay for any extra gigabytes you use. So it says compare the 2 plans and explain what advice you would give Dana if she plans to only use 15 gigabytes of data. So I know no matter what, for number 1, she's going to spend $35. So that's not going to change. But let's go ahead and stick 15 gigabytes of data in here. So I've got 20 plus 5 times 15. And I get 75. So 75 plus 20 is 95, which means that option 1 is for sure the better plan for her. So if she was only going to use, a few gigabytes, it'd be different. But she's using 15 gigabytes of data, so we're going to say option 1 is the better plan. And then 21 through 24 is just asking me to graph lines. I am going to make my pen just a little bit smaller so I can graph a little easier. Come on, drag. Okay. So zooming in, I have y equals 3x plus 2. So that is my slope and my y-intercept. And I know every slope is a rise over run, and that if there's no number in the run section, it's always 1. Because every whole number is got an invisible 1 under it. So I'm going to go ahead and find my y-intercept. That's where I'm going to start at. So from the origin, I'm going to count up 2 and put my point at my y-intercept. And then my slope is just rise over run. So I'm rising 3, 1, 2, 3, run 1. Rise 3, run 1. Rise 3, run 1. And then I'm going to connect my dots. Make sure you put your arrows on the end. And that is the line for that. So number 2. I have a negative line, so I know it should look like this because that slope is negative. So again, here is my M, my slope, and here is my B, my y-intercept. So I'm going to find my y-intercept, 1, 2, 3, 4. And then I'm going to follow my slope. So down 1 over 2, down 1 over 2, down 1 over 2. And you can keep doing that. But again, I'm just going to draw my line through them. So that matches that. Oops, what did I do? All right, number 23, again, I have my slope. What is happening? Why am I erasing? What happened here? Oh, I changed it to white. Okay, so I have my slope and I have my B. So I have my y-intercept is -1 this time, so from the origin, I'm going to go down 1. And then I'm going to rise 3 and run 5. So rise 3, run 5. And I'm going to connect my dots. Y'all hear the wind whipping? If you don't, I'm going to sound insane. But the wind is whipping outside right now. All right, and then the last one, I have a slope of -2. I have a y-intercept of +3. I'm going to put a 1 under there just so I don't forget it. So again, my y-intercept is 3. And then my slope is down 2 over 1. And I can do that several times just to make sure my line is pretty straight. And then it wasn't straight. Let's fix that. It's a little better. Okay. And then that is it for the study guide for Unit 2.